Welcome back. Now we know a bit about what planarity means and which graphs are planar and which graphs are not. So let's look a bit more into the geometry of planar graphs. And one important aspect of that geometry are the faces of a planar graph. So if you have a planar graph, remember that's a graph that you can draw on a plane without intersections. Any plane drawing of this graph partitions the plane into various regions that we call faces. So, for example, we saw last time that the graph K4 has these two plane drawings, among others. And so you can see the bounded regions here. This is a consequence of the Jordan curve theorem somehow, that you have regions here, F1, F2, F3, and F4. And if you draw a different drawing, then you have other regions, say E1, E2, E3, and E4. So the point is that these are the regions consisting of all the points in the plane that do not sit on an edge or a vertex. So as you noticed, one of these faces is unbounded, and that one is called the infinite face, and the others are bounded by the edges of the graph, and they are called the finite faces. So here, as we saw in the first drawing, so these are two different drawings, maybe I should draw a border between them. So here F1, F2, F3 are bounded, they are the finite faces, and then F4 is infinitely large, that's the infinite face. And likewise with E3 in this second picture. Now you might think there is something special about the infinite face, but in fact this is not the case. And if you have a planar graph where in a drawing some face is infinite, you can always redraw the graph in a different way so that in the new plane drawing a different face is infinite. So let's look at how that works. So this works as follows. Suppose I have this plane drawing of my graph, very beautiful. And now, as you can see, the face F4 is the infinite face, and I want to make the face F1 the infinite face. So how do I do this? Well, instead of drawing the graph on a sheet of paper, I draw it on a sphere or any sort of roundish object. So I can always draw any planar drawing on a sphere because the plane can be projected to an open subset of the sphere, of the surface of the sphere. You can think about it this way. Maybe you draw your graph on the floor. The floor is a planar surface, right? But at the same time, the floor is part of the globe. And so since the Earth is round, as we all know, this actually is not a drawing on a plane, but a drawing on a sphere. So now I take my planar drawing of my graph, and I take my sphere and I print my planar drawing on the sphere. So now I have my graph sitting like that on the sphere. What I do now is that I take a point in the face I want to make infinite, in this case F1. I puncture the sphere there. Now, of course, this would ruin the balloon, but if you imagine that the balloon doesn't go all crazy, I will have this hole in the sphere, and then I grasp this hole and enlarge it, and then I get a new plane drawing that looks something like this, where now F1 is the infinite face because I took my hole inside F1. So when I open up the balloon, F1 will be around the sort of boundaries of the balloon. And if I print this on a paper, then F1 will be the infinite face. So what did we actually do? Let's make this a bit formal. So what we did was that we drew the graph on the sphere, because again, if it's drawn on the plane, you can always project the plane onto the sphere, onto that surface, and that is always possible. So you get a graph drawn on a sphere, and then you puncture G in the face. You puncture the graph in the face that you want to make infinite. So let's see what this was. So if you have here the sphere. Again, very beautifully drawn. And then you have a graph like that. And now I take a point, say, here. So I want to make this red face infinite. And if I puncture this sphere and open it up, what I will in the end get is this plain piece of paper with my graph in some fashion. I mean, I'm not very sure about exactly how the lines will go. That depends on how I bend the paper open. But the point is, my point where I punched is now somewhere on the boundary. Rather, I have expanded the hole to be this boundary, and so now this whole thing is my red face. If you are not happy with puncturing the sphere, but you know something about stereographic projection, that is another way to do it. You project. Stereographic projection is a way to project a sphere minus a point onto a plane. So the way to do this is that you put the sphere on the plane and then you project from the point that you have removed. If you are not familiar with stereographic projection, just forget about this part. But anyway, you can make any face infinite. So that raises another question. So, okay, if I can draw the graph in different ways, and the ways can be so different that different faces become the infinite face, how much difference can I really make? I mean, can I draw the same graph in two ways so that in one way I have 4 faces and in the other way I have 5 faces? Does the number of faces depend on the way I draw the graph? The answer is no. That was the answer given by Euler already in 1750. So Euler discovered a beautiful formula that ties together the number of faces, edges, and vertices in a planar graph, or in a plane drawing of a planar graph, and that is what we will look at next.